In this lecture, we're going to write a test. Luckily, everything we need is already installed for us. In the command line, I'm running the vitest server. For the rest of this section, the server should always be running. It'll be able to pick up new tests. We can write tests from the source/components/tests directory. For starters, the project will add an example test file. We can safely delete this file. We're going to start fresh. Next, create a file called example.spec.js. Spec is short for specification. It's common practice to add the spec extension to help developers identify which files are test files. After all, unit tests are written in JavaScript. We don't want to cause confusion. If you think about it, unit tests are specifications for how your code should behave. Each test specifies a result to expect when the function you are testing is called. The first test we'll be writing is what's called a sanity test. If a test fails, you will spend time trying to figure out why it isn't working. In some cases, a test may not fail because of your code. It can be because the tools we're using aren't working correctly. It's common for tools to fail. If a tool fails, we'll need a way to verify it was a tool that failed and not the test itself. A clever way to test this case is by writing a test that will always pass, or at least it should. If it doesn't, we'll know for sure our problem isn't with the codebase, it's with the tool. This is what's called a sanity test. If the sanity test doesn't pass, we know that there's a problem with the tool and not our codebase. I highly recommend writing a sanity test as your first test. We're going to write a sanity test inside the example test file. At the top of the file, import a function called test from the vitest package. Next, call this function. The test function will allow us to write a test that should be included in the report. If you've worked with alternative test frameworks, you may not be used to importing this function. Normally, a library's functions are defined in the global namespace. For vitest, this is not true. However, you may want the same behavior. This behavior can be achieved by updating the configuration for vitest. Open the vite.config.js file. Vitest can be configured from the vite file. At the top of the configuration object, add a property called test. This property is an object of configuration settings for the vitest library. We can enable global variables by adding the globals property with a value of true. By enabling this option, most of vitest's functions will be available in the global namespace. We won't have to import some of the functions from this package. They'll be available immediately. These changes may not take effect until the server is restarted. Back in the command line, restart the test server. Back in the example file, we can remove the import statement. We can freely call the test function without importing it. However, that doesn't resolve all issues. ESLint may throw an error. It does not recognize the test function as a global variable. We can fix this issue by registering it as a global variable. Open the ESLint configuration file. Inside the overrides array, add an object. Vitest's functions are exclusive to test files. We don't need to expose these variables to our application code. Rather than applying these changes to all files, we can apply them to test files. The overrides array can apply settings to specific files. Inside the object, we must add an array called files. The files array can contain a list of files. Let's add the following pattern: source/components/tests/***.spec.js. The pattern we're using will override the settings for files with the spec.js extension from the tests directory. After adding the files, we can add an option called globals. This option is an object of variables that can be used from within our files. ESLint will throw an error if a variable is not listed in this object. Let's add the test function. The value for this property will be read-only. The name of the function must be listed as property name. By setting the variable to read-only, developers will not be allowed to override the variable's value. We'll be limited to calling this function. While we're here, let's add more global variables with the same value. They're called describe, expect, vi before each, and it. In future lectures, we're going to be using these functions. We might as well add them. If we go back to the test file, the errors will go away. Great! Let's get back to writing the test. The test function has two arguments. The first argument is a string that helps us identify the test in the report. Vitest will generate a report with a list of tests that have passed or failed. The value for this argument is the name that will appear in the report. The identifier should be short and concise. The name of our test will be called sanity test. The second argument is a function that'll run when we test our application. We'll pass in an arrow function. We're going to create what's called an assertion. In the software development world, an assertion is an expression that evaluates to either true or false. It's as simple as that. If the assertion we create evaluates to false, the test fails. If the assertion evaluates to true, the test passes. We're going to create an assertion that checks if the Boolean value true is equal to true. We can use a comparison operator to create this expression, but Vitest has an even better solution. Inside the function, add the following: expect true to be true. We're using another global function defined by Vitest called expect. This function will return an object with functions that can be used to test the value passed into it. In the resource section of this lecture, I provide a link to the expect function. The expect function takes in a value. It can be any type of value. It'll return an object with methods you can use to perform a test on the value you passed in. On this page, there's an extensive list of functions that can be called. One of the functions is called toBe. The toBe function can be used to compare primitive values. Let's review the test report. As you can see, the sanity test has passed. That's the goal of a sanity test. We're creating a test that will always pass to check if the tools we're using works. If the test doesn't pass, we'll know that there's a problem with the tool and not our tests. Before I end this lecture, I want to talk about one more thing. Back in the editor, we're using the test function to run a test. There's an alias for the test function called it. In some functions, you may find developers use the it function instead of the test function. We can swap this with the it function. There isn't a difference between the two functions. They do the exact same thing. The it function was introduced for those who prefer to write less code. For the remainder of this course, we're going to continue using the test function.